Hypothesis testing is commonly used in business, science, healthcare, and many other fields. It can also be applied in genetic genealogy. Genetic genealogy combines DNA evidence with traditional genealogical research to determine family relationships and ancestral origins. In this presentation, we will examine how hypothesis testing can help researchers determine whether a group of individuals shares a common ancestor and discuss the importance of data quality, evidence evaluation, and continuous investigation. Hypothesis testing is a structured method used to evaluate whether available evidence supports a proposed explanation. Researchers begin by identifying a question and creating a hypothesis. Data is then collected and analyzed to determine whether the evidence supports or contradicts the hypothesis. The goal is not to prove something is true beyond all doubt, but to determine whether sufficient evidence exists to support a conclusion. Imagine a genealogist discovers a cluster of DNA matches that all appear connected to a colonial family from the 17th century. The researcher wants to determine whether these individuals truly share that ancestor or whether the DNA similarities result from another relationship. This becomes the central research question that drives the investigation. In statistical testing, researchers typically establish two competing explanations. The first is the research hypothesis, which proposes that the DNA matches descend from the same ancestor. The second is the null hypothesis, which assumes that the observed DNA sharing is due to chance, another ancestral connection, or some other explanation. The purpose of the analysis is to determine which explanation is better supported by the available evidence. To evaluate the hypothesis, researchers collect multiple forms of evidence. Autosomal DNA identifies shared genetic segments between individuals. Shared centimorgan values provide estimates of genetic relatedness. Family trees help establish documented relationships. Historical records such as census records, wills, land deeds, and probate files provide supporting evidence for ancestral connections. Combining multiple evidence types strengthens the reliability of conclusions. One major challenge in genetic genealogy is data quality. Many online family trees contain mistakes that are copied repeatedly across multiple websites. If researchers rely on inaccurate trees, they may create incorrect hypotheses and misleading conclusions. Careful source evaluation and verification are essential components of the research process. Another factor affecting genetic genealogy research is endogamy. Endogamy occurs when individuals marry within a relatively small population over many generations. Pedigree collapse occurs when the same ancestor appears multiple times within a family tree. Both situations can increase DNA sharing and make relationships appear closer than they actually are. These factors can complicate hypothesis testing and must be considered during analysis. Sample size can significantly affect research outcomes. If only a handful of descendants have tested, the available data may not accurately represent the broader descendant population. Larger sample sizes provide more opportunities to identify patterns and reduce the likelihood that conclusions are based on unusual or isolated results. Increasing participation often strengthens the quality of the analysis. Researchers evaluate whether the evidence consistently supports the hypothesis. Strong conclusions typically emerge when multiple forms of evidence point toward the same answer. DNA evidence alone is rarely sufficient. Historical documentation, family relationships, and replication across independent descendant lines help strengthen confidence in the findings. Sometimes the available evidence is insufficient to confidently support a conclusion. Researchers may encounter conflicting records, inconsistent DNA results, or limited participation from descendants. When this occurs, the appropriate response is not to force a conclusion, but to gather additional information before proceeding. When evidence is limited, researchers can take several steps to improve the investigation. Additional descendants can be recruited for DNA testing. Documentary research can be expanded to include more historical sources. Y-DNA testing can help trace direct paternal lines, while mitochondrial DNA testing can assist with direct maternal line investigations. These additional data sources may provide stronger evidence for evaluating the hypothesis. Data analysis often benefits from collaboration. Experienced genealogists and DNA project administrators may identify patterns, errors, or alternative explanations that were initially overlooked. Subject matter experts can also provide valuable historical context and guidance regarding specialized populations or geographic regions. Consulting experts improves both accuracy and confidence in the final conclusions. One of the most important lessons from both data analytics and genetic genealogy is that research is an ongoing process. New records become available, additional individuals test their DNA, new evidence may strengthen or challenge previous conclusions. Researchers must remain open to revising hypotheses when new information emerges. Continuous improvement leads to more reliable and accurate results. Hypothesis testing provides a valuable framework for evaluating genealogical questions. By combining DNA evidence with traditional records and careful analysis, researchers can assess whether a proposed ancestral relationship is supported by the available evidence. The goal is not simply to reach a conclusion quickly, but to ensure that the conclusion is based on reliable, sufficient, and well-documented information. This same principle applies across all fields of data analytics. Quality decisions depend on quality data. Thank you for watching this presentation on hypothesis testing and genetic genealogy. As we've seen, reliable conclusions are built through careful research, quality data, DNA evidence, historical records, and ongoing analysis. Whether you're exploring your own family history or conducting professional genealogical research, remember that every new record and every new DNA match has the potential to add another piece to the story. If you enjoyed this presentation, please like, subscribe, and share to help support future genealogy, history, and DNA education content.